Dear students, when you see around yourself, you see the fascinating creation of God, the green world. Now, this world looks green because of the tree. These trees are green and they are very important, very vital part of the life on this earth. Now, these trees or plants, they are of two different types. One is the flowering plants, and the other one are the non-flowering plants. The flowering plants and the non-flowering plants. Now, if you see the trees or the plants, they are present everywhere. They are present on water, they are present on land. They are present in the water. The plants or the trees which are present on the water are called hydrophytes. Those on land are called mesophytes. Sometimes you see the trees or the plants growing in desert region also, or in scarcity of rain. That is, those are the xerophytes. So plants are present everywhere, trees are present everywhere. They accommodate, they adapt themselves to the climatic conditions where they survive. Now, these are the two basic divisions of the plant kingdom. One is the flowering plants and the other one is the non-flowering plants. Today's topic is about the leaf. When you see a plant, you see different parts of the plant. Some part of the plants which is above the soil, some part of the plant which is below the ground or below the soil. So we have different parts of the plant. But the most important part, one of the important part of the plant is the leaf. We need to talk about leaf, what is the structure of the leaf, what is the function of the leaf, different modifications of the leaf, and all this. So today we'll start our class with leaf. Before that, I need to give you two important informations. I told you about the trees. These trees could be very tall or they could be wide. The tallest tree, the redwood tree in California. Redwood tree is the tallest tree. It measures something about 91 or 92 meters. You can imagine. So these are called redwood trees. Redwood because the wood, it looks red in color, so it is redwood tree, and these are the tallest trees in the world. Widest tree, that means number of branchings or the canopy of the tree spreads to a very large extent, and that is Ficus bengalensis, the great banyan tree in Kolkata, the zoological park in Kolkata. That is the widest tree. So these are the two important facts you should know. So we coming to the main topic, the leaf. Now the leaf, I told you, it is one of the important and most vital part of the plant because this leaf, it makes the food for the plant, of course for the plant, and for other living organisms that cannot make the plant to depend on the green plants for the food. Say for example, we human beings, we cannot make the food. We depend on the green plants for food. Now this green plant, they make the food with the help of leaf. So these leaf are, yes, they are the most important and the most vital part of the plant. Leaf, first we talk about the structure of the leaf, how this leaf look like and what are the different parts of the leaf. So a leaf is attached to the stem. A leaf is attached to the plant with a stem or with a stalk. A leaf is attached to the stem of the plant with a stalk, and this stalk is called petiole. So petiole is one of the structure of the leaf. The petiole, the stalk with the help of which the leaf is attached to the stem, and the second one is the lamina, the flat broad part, the green part of the plant, that is the lamina. It's sometimes called as leaf blade also. Leaf blade. So leaf has a petiole with the help of which it is attached to the stem. A leaf has a broad green part which is called the lamina or the leaf blade. Now sometimes you may be seeing some leaf without this stalk. The leaf may have the stalk or it may not have the stalk. So if the leaf is with a stalk, it is called a stalk leaf. Leaf with a stalk is a stalk leaf, and the leaf that doesn't have any stalk, which is where the stalk is absent, is called a sessile leaf. Sessile leaf. So I'll give you an example. Stalk leaf. Suppose you see a leaf of a mango plant or guava, the leaf is present with a stalk. So these are the stalk leaf. All the dicot leaf or the dicot plants. Dicot plant is a plant whose seed has two cotyledons. So the leaf of a dicot plant is stalk leaf, and the leaf of monocot plant, sessile leaf. Monocot plant is a plant with only one cotyledon in the seed. So those are the monocot plant. Example: dicot plant or the stalk leaf is mango, and example of sessile leaf or monocot plant is maize or banana. Banana is also monocot plant. Banana, you don't have any stalk in banana leaf. Okay. Now moving on to the main structure into which the stem, the leaf is attached. I told you that is stem. Now before that, I told you a plant has two important parts. A part which is present below the soil. This is the soil. The part of the plant that is present below the soil, and the part of the plant that is present above the soil. The part that is present below the soil is the root or the root system. The part which is present below the soil, this is also called underground part. This is called the root system, and the part of the plant which is present above the soil is the shoot system. So this is the shoot system. The root contains a primary root. This is the main root or the primary root, and then it has branches. These branches are the secondary roots. You know, the roots are non-green because it doesn't contain any chlorophyll. It has got no role in manufacturing of the food. So these are non-green part, and they mainly help in anchoring the aerial part of the plant. The plant which is above the soil, it is anchored. It is supported by its roots. That is one of the important functions. The second function is, you know, for photosynthesis, for making the food, plant needs two important things. One is carbon dioxide from the atmosphere and water that is from the soil. Apart from that, plant also needs mineral for proper growth. So those minerals and water is absorbed from the soil, and that is done by this root. First, the root, they provide anchorage to the plant, and second, they help in absorbing water and the minerals from the soil, and then they help in transporting to the different part of the plant. So these are the two important functions of the root. Next, come to the shoot. The shoot is the aerial part of the plant. Aerial means the part that is present in the air. This shoot is the aerial part of the plant. It is present in the air. It has got different structures. It has got branches. It has branches. It has leaves on the branches. Leaves, it has flower. Again, an important part of a plant, a flower. So it has flower also, and it has fruit. So this stem bears leaf, it bears flower, it bears the fruit. The leaves are the part of the plant which helps in manufacturing or making the food for the plant, as well as for the living organisms that cannot, or that those depend on the green plants for food. So this is the aerial part of the plant. What is the function of the stem then? This stem, the mineral and the water which is absorbed by the root is transported to the leaf. It has to be transported to the leaf. Water is transported to the leaf because it is the site where the food is manufactured. So this water is transported to the leaf with the help of this stem, and the stem bears all other parts of the plants. So we take up the leaf. I told you the leaf, the structure of the leaf. Now, this leaf, it can be of two different types. Leaf can be of two different types. You must have seen the leaf of a neem plant. It looks something like this. Neem or tamarind. This leaf looks something like this. This is the structure of a leaf of a tamarind or neem plant. Now this type of leaf, this is the stalk with the help of which This leaf is attached to the stem. Now this top is called the rachis. Not the petiole, it is called the rachis. And this type of leaf is called a compound leaf. This is a compound leaf, where the leaf blade or the lamina is notched. It is cut into small leaflets. You see, these are the leaflets. Actually, this was the leaf. This was the leaf. This was the leaf blade. And this leaf blade was cut into small notches. And these are called the leaflets. These are the small leaves and the leaflets. So, this type of leaf is called a compound leaf. Example I gave you is neem or tamarind. These are the even gulmohar. These are the examples of compound leaf. Next, come to the simple leaf. Mango, guava. These are simple leaf. A stem, it contains a stalk and then it has a leaf. These are simple leaf. Example is mango, guava, jackfruit. These are the simple leaf. The inside the leaf, you see, there is a vein. This is called the mead vein. This is the mead vein. What actually is the function of this mead vein? The water and the minerals which are conducted through the stem, it has to go to the leaf. From the stem, it goes to the mead vein and then into the leaf. So there is a network of veins in the leaf. This network of vein is called venation. The arrangement of leaf is called venation. So these are the veins. Midrib, midvein and the other veins. Two types of arrangement you see in the leaf. One is called the parallel venation. And the second one is reticulate venation. Parallel venation and reticulate venation. You must have seen the leaf of a banana or maize. It looks something like this. This is the midvein. This is the leaf blade. This is the leaf blade. And the veins are parallel to each other. They are parallel to each other. This is called parallel venation. Example is banana. Reticulate venation. Again, example is mango. You must have seen a mango leaf or a people leaf. This is the leaf midvein. This is the leaf. And the venlets, they are arranged in a network to form a network. This is what is called reticulate venation. So we have parallel venation. Example is banana. All the monopod plants, banana, they have parallel venation. All the dicot plants in mango, all the dicot plants, they have reticulate venation. So these are the two different types of leaves. Next we move on to the function of the leaf. What is the main function of the leaf? I told you, leaf, they have, though the important function is photosynthesis, you must be doing that. They help in making the food for the plant itself and of course for the living organism who depend on the green plants for food. That is one of the important functions. But other than that, it has got two more functions. One is transpiration, the other one is respiration. So we have three functions for the leaf. The first one is photosynthesis, then transpiration and respiration. Photosynthesis, transpiration and respiration. We'll take a photosynthesis first. Now this leaf, they look green because they have a green pigment called chlorophyll. The green pigment that is present in the leaf is the chlorophyll, and this green pigment, the chlorophyll, it has a unique feature. It has a unique function. It can trap the solar energy. It can trap the energy of the sunlight. Now with the help of this energy, it helps in manufacturing the food, that is glucose. Glucose is the food that is manufactured by the plant. So this leaf, they have chlorophyll. This chlorophyll traps the solar energy, and the raw materials for the photosynthesis are carbon dioxide and water. These are the two raw materials for the photosynthesis that is carried by the plant. You know, carbon dioxide is present in the atmosphere. So the leaf can take the carbon dioxide from the atmosphere. The leaf have got certain structures with the help of which they can take the carbon dioxide from the atmosphere. These structures are called the stomata. Stomata are small pores, very small, very minute pores, microscopic pores that are present on the lower surface of the leaf. Generally, they are present on the lower surface of the leaf. They are small openings. They look something like this. These are small pores. You see the pore inside. So through this pore, carbon dioxide can get into the leaf, and with the help of this carbon dioxide and of course water, this water is absorbed by the plant from the soil. The roots absorb this water and it conducts the water through the stem and to the leaf. So the leaf has carbon dioxide, which it has absorbed from the atmosphere. It has water, which was conducted to the leaf through the stem by the roots. So now these are the two raw materials for the photosynthesis. With the help of these two raw materials and the energy of the sun, that is the solar energy, which was trapped by the chlorophyll, is used to manufacture the food for the plant, and that food is the glucose. Immediately during photosynthesis, glucose is manufactured, and then this glucose is stored in the different part of the plant, storage part of the plant, as starch. So this glucose, which is the immediate product, immediately during photosynthesis, glucose is manufactured and then it is converted to insoluble starch and is stored in different parts of the plant. We human beings or animals, heterotrophs, that means those who depend on green plants for the food, they feed on the starch that is present in the plant or the leaf. So we get the food from the plant. Now I can show you with the help of an activity how or is it true or is it really that the plant manufactures starch in presence of carbon dioxide, water, and of course with the help of solar energy. We have an activity that I will show you later on, but before that we will go to the next function, that is transpiration. Transpiration. One very simple thing you must have heard. The region which has large number of trees, or suppose forest area, or suppose you go to the Amazon basin, some forest area, they receive more rainfall. There is a logic behind that. It is because the trees or the plants which absorb water from the soil, they give out this water in form of water droplets or in form of water vapor. Plants, they give out water in form of water vapor. Most of the plants, when they absorb water, most of this water, 97 to 98% of water that the plant absorb from the soil is transpired back or is given out in form of water vapor. Now this is called transpiration. Transpiration is the loss of water by the plant in form of water vapor. Now plant transpires. You must be thinking, then what is the use of giving water to the plant, or why the plant absorbs so much of water from the soil? Yes, it loses most of the water, but then it has got certain benefits also. First is, this plant stands in the sun for so many hours. This plant, it keeps itself cool because of this transpiration. I told you transpiration is the loss of water in form of water vapor. So this water vapor, when they are transpired by the plant, it remains in the surrounding and it gives a cooling effect to the plant. So the plant keeps itself cool with the help of this transpired water. So that is one of the important functions. That is, it helps in cooling effect, giving cooling effect to the plant. And second is, when the plant transpires, it creates a suction force. It creates a vacuum. With the help of this suction force, the plant is able to absorb or suck the water from the soil. It's same as you do when you bring cold drinks from a bottle. You are provided with a straw. You suck the straw. When you suck the straw, the liquid in the bottle, it moves up into the straw and goes into your mouth. Similarly, when the plant transpires, it creates a suction force. And with the help of this suction force, the plant is able to absorb the water from the soil and it takes that water to the different part of the plant. So that is absorption of water. Not only water, even the minerals Even the minerals, the fertilizers you provide to the soil, plant, those fertilizers you provide in the soil. So they mix up with the water, they move up with the help of the suction force, and then they go to the different part of the plant. So this is another function, transmission. The third one is, for carrying out any activity, you need some energy. Suppose you play, you need some energy. You take food for that. Even plants also, they do so many. The plant may be standing outside in the soil, but then they are doing so many activities. Photosynthesis, one of the important functions of the plant. It needs energy for this. This energy comes from the food that they manufacture, or even are also. We get the energy by the food. If you don't take food for 2 or 3 days, you won't be able to do some work, any work. Plant also, they need energy. Now this energy comes from the food that they manufacture. They manufacture starch. It's not simple. This starch or this glucose, it has to be burned. Then only it can give energy. Now this burning of glucose is what is called respiration. This glucose is burned in presence of oxygen. Sometimes in absence of oxygen also. Glucose is burned in presence of oxygen, and then it releases energy. With the help of that energy, plant is able to carry out its activities. Now I said for respiration, for energy, you need oxygen. We breathe through our nose, we breathe in oxygen. This oxygen, it helps in burning the food. Similarly in plants also, they have starch, they have glucose. That glucose is burned in presence of oxygen. Now you may say, plant, how do they breathe oxygen? You must never have heard plants breathe oxygen. Plant breathe oxygen during certain hours of the day. During photosynthesis, one of the best product of photosynthesis is oxygen. During photosynthesis, plants give out oxygen. It is the same oxygen that we breathe in, and some of this oxygen is utilized by the plant itself to carry out respiration. But during the night hour, plant don't carry out photosynthesis. Because there is no sunlight, there is no photosynthesis. If there is no photosynthesis, there is no liberation of oxygen. If there is no oxygen, plant cannot respire during the night hour. But yes, plant respires because energy is needed in your body every time, every moment you need energy. During the night hour also, it's plant need energy, and that energy comes from burning of the glucose. For this, plant needs oxygen, and this oxygen is taken up by the plant from the atmosphere. So during the night hour, plant taking oxygen from the surrounding, and in the daytime, plant take up carbon dioxide from the surrounding. So with the help of this oxygen, plant, they burn the glucose and it gives the energy. So that is respiration. So these are the 3 important functions of the plant. Next I'll tell you an activity just to prove that the plant produces or it manufactures glucose. So for that, what we need is first green plant, well watered, well potted, kept in the sun. Green plant. Why sun? Because unless you keep the plant in the sun, the plant cannot manufacture food. It cannot carry out the process of photosynthesis. So the plant has to be kept in the sun. Now you take the plant, single leaf from the plant, and you boil that leaf in a beaker with water. Take a plant from a water and well watered, kept in the sun, a plant, a leaf. Take that leaf in a beaker, boil this water. Boil this water. After you boil this water, leaf in water, you take out that leaf and containing ethyl alcohol. Ethyl alcohol, sometimes also called as ethanol. Ethanol, it is also called ethanol. So you take some amount of ethyl alcohol in the test tube. Now take this leaf, after you have boiled that leaf in water, put this leaf in the test tube with the help of a faucet. Now the leaf is placed in the test tube. Take this test tube and put the test tube in the beaker with warm water. So the test tube is now kept in the beaker with the leaf here. Again you start boiling. The water. Why so? It is because we need to boil this alcohol. But alcohol is highly flammable. If you start boiling the alcohol, it will catch fire. So we need to boil it indirectly. So we keep this test tube in a beaker containing water. You boil the beaker, you warm. So when you boil this water, the ethyl alcohol also get boiled, and the leaf, it starts losing its chlorophyll. So ethyl alcohol now becomes green, and the leaf becomes pale white. You can easily now, if you want to test the presence of starch, you can do it now easily, because earlier when the color is green, you cannot get the color of the starch. So after boiling, you take out this leaf. After boiling it in ethyl alcohol, take out the leaf with the help of a forceps and spread it in a watch glass. Spread the leaf in a watch glass. Put some iodine solution. Put some iodine solution in this watch glass containing the leaf. You know, the color of iodine solution is brown. It is brown color. The iodine solution is brown in color. It is a liquid. You put this iodine solution in the beaker, in the watch glass with the leaf. After some time, you see the leaf starts turning blue-black. Sometimes it is also called dark blue or deep blue. Even boiled culture, it's also called boiling. So this leaf, after you put some iodine solution in this leaf, the leaf starts turning blue-black or deep. Now this changing of the color of the iodine solution from brown to deep blue indicates that there was starch present in the leaf. So by this activity, we can prove that the leaf has manufactured starch during photosynthesis when the plant was kept in the sun.